Let's take a look at the parts of an ellipse and how they relate to one another. We will start first with a vertical ellipse to sort of construct these ideas, and then we will work in reverse to do the horizontal ellipse, so you'll get a different perspective in each case. So a vertical ellipse looks something like this, and the first thing you need is the center of the ellipse. So every ellipse has a center. Okay, that's pretty obvious what that is. Now, the center is your reference point for an ellipse. Reference point, and we always measure from the center when we do work with ellipses. Okay, now once you have your center, then you have 4 points basically to construct the ellipse. You have points above and below the center and points left and right of the center. Okay, now what happens is the points above and below the center when you're looking at a vertical ellipse are further apart than the points left and right of the center. The distance, or this axis from the top point to the bottom point, that is called the major axis. Okay, the major axis. And the major axis is the axis along the length of the ellipse. And by length I mean the longer dimension. Okay, so I'll call top to bottom the length here. And then of course if that's the major axis, then running the other way all the way across the ellipse is what we call the minor axis. And the minor axis, of course, you could probably guess, is the axis along the width. And it, of course, would be shorter. Okay? Okay, so now that establishes these lengths, or these axes, and the points at the ends of the major axis, the endpoints there, are called vertices. So this point up at the top is called a vertex, and the point at the bottom is called a vertex. Okay? When you have more than one, they're called vertices. So they are the endpoints of the major axis, and they are on the curve. So what I mean by that is, notice the center is not a point on the actual ellipse curve, but the vertices are points on the curve. Okay? Then we have these 2 points over here. They're not really too special, so we call them the endpoints of the minor axis. So this one over here is an endpoint of the minor axis, and so is this one over here, endpoint of minor axis. And those are self-explanatory. Then we have 2 more points that the curve wraps around, and they live between the center and the vertices. So I'll have one of those points up here and one of those points down here. Those are called, each one of those is called a focus. When you have 2 of them, they are called foci. And the foci are points on the major axis that the curve wraps around. Okay? So the vertices and the foci in the center are all on the major axis. Okay? Alright, now there is a relationship between the foci, the endpoints of the minor axis, and the vertices. Okay, so we'll get to that shortly. Let's now leave all of this information here and construct a horizontal ellipse. So now I've explained the meanings of all these parts of an ellipse over here. We'll work in reverse to place them into the horizontal ellipse, hopefully strengthening our understanding of these ideas. So the center, of course, will be right in the center. That's pretty simple. Then we've got the major axis, which runs along the length. So in that case, that's from left to right, not right to left like it was before. So there's our major axis. Our minor axis runs along the width, so that'll be top to bottom now, or bottom to top. Then we have our vertices. The vertices are the endpoints of the major axis. A horizontal ellipse, the vertices are left and right of the center. So this is a vertex, and this is a vertex. Then we have the endpoints of the minor axis. Well, that's pretty simple, self-explanatory. Endpoint of minor axis and endpoint of minor axis. And finally, the foci are points on the major axis that the curve wraps around. So this might be a focus, and this might be a focus. Okay? And there you go. We've worked in reverse now to place all of these parts of a horizontal ellipse using the descriptions we've described before. Now let's get to how the distances relate. Alright, so what we have is, I'm doing this for a vertical ellipse, but it could also be for a horizontal, and to make it have a little more room, I'll make it wider. So we have our center, and from our center we have the endpoints of the minor axis, we have the vertices, and we have the foci, maybe like right here. Okay, so this is our center, this is an endpoint of the minor axis, this is a vertex, and this is a focus. And similarly the others could be labeled the same. Now we're going to get three distances. Three distances: A, B, and C. Now this could be different depending on what textbook you're using, but A, B, and C are common variables to use for the three distances. So label A is distance from center to vertex. Okay, so A is this distance right here from the center to a vertex. It could also be measured from the center to the bottom vertex. It doesn't matter. Okay, then B is the distance from the center to an endpoint of the minor axis. So B is this distance. Okay, and finally, I'm sure you could guess what C is. The C is the distance from the center to a focus. Okay, so C is the distance from the center to a focus. And of course I could have measured all these left, right, up, or down, but I'm being consistent using the top right corner of the curve. Now these are labeled the same way for a horizontal ellipse as well. Now the relationship between these distances is as follows. We usually start with C, and this is very similar to the Pythagorean theorem if you're familiar with that. If not, I won't go further into it, but it'll look similar. So you start with C squared equals A squared, and the Pythagorean theorem is usually plus B squared. Okay, but for an ellipse that's not what it is. Okay, not the Pythagorean theorem. Now, that wouldn't make sense anyway, right? If you want to know c squared, you could add a squared and b squared. If you did, that would mean c is the biggest distance because you'd basically have to be adding a and b to get c, all right? C is not bigger than A. A is always bigger than C. You can tell from the picture. A vertex is always further away than a focus in an ellipse. So instead, we have c squared equals a squared minus b squared. A is the biggest distance. We have to subtract from it to get c. Alright, so we have to take something away from A to get the smaller distance c, and that's usually what helps me remember this equation. So c squared equals a squared minus b squared. So let's go look at an example of this now. We'll do a horizontal ellipse just so we understand that this works for any ellipse. If I have, this is my center, this is a vertex, this is an endpoint of my minor axis, and I want to know where a focus is, let's say. Let's say that I tell you that this distance is 7 and this distance is, let's say, 3. Then we know that A is 7 because this point here is a vertex, right, because it's on the major axis. This distance here is B because that's to the end point of the minor axis, and I want to know where the focus is, so I want to know what C is. Now my equation for an ellipse tells me that c squared equals a squared take away b squared. So c squared equals 7 squared minus 3 squared. So c squared is 49 minus 9, so c squared is 40. And if I take the square root of both sides, I see that c is the square root of 40. Or if you simplify it, you get 2 square roots of 10. I don't have a preference here. Actually, I do. I prefer the square root of 40 over 2 square roots of 10. And if you wanted to give an approximation, so this is exactly the value of c. An approximation, c is approximately 6.3 units. And so that means if I wanted to locate my focus here, I would measure 6.3 units on my major axis from my center. So I'd go 6.3 units this way, and this would be a focus. And that would be 6.3 units from my center. If I wanted the other focus, I'd measure 6.3 units the other direction. And this would be another focus. Of course, this would be another vertex as well, and this would be another endpoint of the minor axis. Okay, so the key here is, don't forget that A, B, and C are all measured from the center. I can't stress that enough. A is not the distance all the way across the ellipse. It's measured from the center to the vertex. B is from the center to the end point. C is from the center to a focus. Sorry, I wrote this as foci. I meant focus here. Okay? And so that's just one example. Of course, you don't always find C. Sometimes you know C and A and need to find B. Okay, so when you look at this equation here, if we know any two of the distances, we can use the above equation to find the third distance. Okay, so it just depends on the problem that you're solving, but it's important to know that since there are 3 variables in that equation, you have to know 2, and then you can find the third one.